Hello class, and welcome to another episode of Professor Choice. Never mind, it's not an episode. Alright, anyway, so here we are today. We're going to be talking about what a regression analysis is. Now, in Intro to Statistics, the regression analysis that we normally do is a sort of simplest type of analysis where we make an assumption that a regression, the relationship between the variables is linear. So what we're going to study today is what we call a linear single variable regression. So we're making the assumption that the analysis between the two variables is linear, and that we're only going to be using one variable, one independent variable, so we can get a dependent variable. Alright, so what exactly is a regression? A regression is basically a best fit line to a set of points, x and y. So it's a line that provides the best fit to a set of 2 points that you have, or 2 variables. An example of something like this is, imagine that you have 2 things that you think are related. Something like the age of a car and the maintenance cost of that car. As we know, when cars get older, we have to maintain them more. Now imagine that you found a bunch of points between those two. In other words, you have to collect a particular car age, let's say a 10-year-old car, and then you have to collect how much maintenance costs per year on that car. And then you collect another car, say a 1-year-old car, and then the maintenance costs on that car, and so on. So you have to collect lots of maintenance and collect lots of costs for those cars. Now once you collect that information, you can create a sort of plot diagram. Now imagine that this is your plot diagram. Alright? So you got your graph, you got your plot, and those points are basically these points here with x on the bottom and y at the top. Okay? Now the regression is basically that red line that you see right there. So a regression is a line that provides a sort of best fit or best estimate of those points. Okay? Alright, now regressions have an error because, of course, since you're fitting a line to a bunch of points, you're never going to find exactly a line that's wide enough. I guess we could, by the way, if we got like a marker this thick, then I can create a line like that. But anyway, that's not the point. But the point is that a regression is not a perfect description of all the points. It's just sort of a description of the center of the point, or where the points are more related. Alright, and notice that in this case, if that is the point distribution, then I'm going to have a sort of upward sloping line. Alright, now imagine that we have a couple of other things. So all the lines don't really need to be nice and straight up. We could have something like this, where we have a bunch of points that instead, when you're going to do a best fit line, they look kind of like downward sloping. Alright, so these are 2 points that will be negatively related. Okay? We could also have something like this. And this is the sort of relationship that doesn't really have a line. Now one of the problems of fitting a line into a set of points is that you're always going to get some kind of line. So if we have something like this, you're still going to get something like that if you run a regression. The problem is that your regression will not be very strong. It will be fairly weak. Alright, now, how do you know the strength of something like this? Well, that's where the coefficient of correlation comes in. That's where that R comes in. Alright? Now the coefficient of correlation basically tells you how related are 2 variables. And in our trusty, okay, so here we can find the formula for the coefficient of correlation, which is the correlation coefficient. So this is basically the summation of x minus x bar, y minus y bar, all of that divided by n minus 1, and then the standard deviation of x and standard deviation of y. Alright? So this is my correlation coefficient. A correlation coefficient tells you about how related the two variables are. And in this case, the two variables will be x and y. All right? Now, correlation coefficient goes from 0, positive 1, to negative 1. So if you're like, say, a third of the way, maybe 2/3 of the way, or maybe all the way, a correlation coefficient of 1 will basically be describing a line that looks like this. In other words, the 2 points are perfectly related, perfectly correlated. All right? Whatever the x and the y are. Now, if you have something like a negative 1, then a negative 1 describes something like that, where the two x and y's are perfectly correlated, in this case negatively. So when one goes up, the other one declines. And then anything in the middle will describe something else. Alright? Now, if we are somewhere around here, we can say that there's a weak correlation. In this case, positive weak correlation, negative weak correlation. If we were somewhere around here, we can say strong positive correlation or strong negative correlation. And then over here we can say something like moderate positive correlation or moderate negative correlation. Okay? Now, when you are trying to build a regression line, once you find your correlation coefficient, you need to figure out which variable do you want to set up as your dependent variable and which variable you want to set up as your independent variable. Your dependent variable is going to be your y, and your independent variable is going to be your x. So basically, you're going to be plugging in an x into the model so you can obtain a y out of the model. And that's why one has to be dependent and the other one has to be independent. So in other words, y is dependent on x because you're plugging in x to get y. Alright, so what we're going to proceed right now is an example of a linear single variable regression of this particular form. We're going to have y equals a plus bx. X is variable x. Y hat is my estimate of y. That's why we put the hat on. And then there's going to be an error. Alright? Now remember, if we were looking at a relationship like the one that I should show you, something like that, then the center will be my line, and then the plus or minus will be that error. And the error just sort of describes like how far the numbers are from the line. Okay? Now we're not going to focus too much on the error. This is how you find the standard error of the estimate. Okay? So this is how you find that error. We're going to focus on this portion here, which is sort of creating the line. Alright, so a few years ago I started looking at the data in my exams between exam 1 and exam 3 on my statistics class, and I had a hunch that there was a relationship between exam 1 and exam 3. In other words, the students that were doing well in exam 1 were also doing well in exam 3, and the students that were not doing well in exam 1 were also not doing well on exam 3. In other words, what I was kind of noticing is that if you did well at the beginning of the semester, you kind of do well at the end of the semester. This was a bit troubling because you would expect, that people can change or learn more as time goes by, and that is true. But I noticed that a lot of the results in my class had to do with the level of preparation that a student had before they enter my class. So in other words, if you were highly prepared to be in the class, it basically meant that your test 1 score was going to be fairly high. And then if you were not very prepared to be in the class, then your test 1 score was going to be fairly low. And unfortunately, my hunch was that that relationship would carry through the entire semester. And then the students that were well prepared to be in the class were going to end up doing very well in the class, while the students that were not very well prepared to be in the class would end up doing not very well in the class. And then I conducted a relationship study or a regression study for that. Alright? And this is what I got. So I conducted a study of 30 students that took my class at that time, and I conducted a relationship study between test 1 and test 3. Now, I wanted to use my test 1 as my x and my test 3 as my y. So again, my x is going to be my independent variable, and my y is going to be my dependent variable. So the first thing I did is I took my r. So I went ahead and I calculated the coefficient of correlation between the two variables, test 1 and test 3, and I got a really strong r. I got a 0.8. Now, it doesn't get much better than a 0.8 in real life, all right? So this is very good evidence that my hunch is sort of correct, okay? Then I calculated my mean for my x, which is my test 1 score, and that number was 77.6. And then I calculated the standard deviation for x, and that gave me 16.26. Then I calculated my mean for y, which is test 3, and I got 73.5. And then I calculated my standard deviation for y, and that gave me 22.31. Alright? Now with this information, I have enough information to start building my regression equation. Let me get my trusty calculator here. Alright? Now the form of the regression we already have. So that's the type of regression that we're going to be building. Now to find b and plug it in there, I need to do that calculation. So to find b, I got to do r, which is 0.8, and then I got to multiply that times sy, which is standard deviation for test 3 in this case, and then I got to divide it by sx, which is the standard deviation for test 1. Alright, and then I get b equals 1.098. Alright. Now I can also calculate my a. To calculate a, I gotta do y hat, which is my mean for test 3. So that's 73.5. And then I gotta subtract b, which is what I got here, 1.098. And then I gotta multiply that times x bar, which is 77.6. Okay, so again, I gotta do this times that, and then that has to be negative. Take it away from that. So 73.5. 1.098 times 77.6. Okay, and for my a, I got negative 11.70. Okay? Alright. Now what exactly does this mean? So now once I calculated my a and my b, I can create my regression equation. Let me take this formula out of here, I don't need it anymore. So now with this information, I can create my regression equation. So my regression is going to be y hat equals, a is this number here, and then I'm going to add b, which is this number here, times x. And again, we're not going to focus too much on the error for now, we're not going to do that in this portion. So let's just focus right now on my line, and let's not worry too much about the standard error. Now before I move on, I need to remember that in order to build a regression, you must have already taken some basic statistics, because everything that you see here is already a formula on its own. So you have to learn how to calculate the mean, you have to calculate learn how to calculate the standard deviation, and then you have to learn how to calculate the coefficient of correlation. Alright, so a regression analysis is something that you do towards the end of intro to statistics class, or maybe on like statistics 2. if you don't do it on statistics 1. Okay? So, in any case, once I calculated my A and my B with the information that was needed, now I got my, my regression equation. Now this regression equation, what it's basically saying is that out of the points that I obtained, and remember my X was test 1 score for that class, and my Y was test 2 score for that class, then my y-intercept is going to be at a negative 11.7. So I'm going to start here my line at negative 11.70. And then the line is going to be upward sloping by 1.098. Like that. So again, the slope is going to be 1.098 upwards for every 1 to the right on x. So 1.098 to 1 is my slope. And this represents my y hat. Alright? So this is my regression equation. Now, I don't have a plot right now for all the points, but the idea is that my regression equation is supposed to be a best fit line for all the test scores that I saw. So if you look at the same student, test 1 and test 3, they will basically be all sort of like clutter around that. Now, what exactly is the purpose of a regression equation now? Well, imagine that now I want to create an estimate for a test score. So let's say once I have my regression equation, let's say that Professor Choi wants to get an estimate for how much he's going to get on test 3, and we're going to be using test 1 as our way to figure that out. Now I know that the relationship between the two is really strong because if you remember that R was 0.8. Alright? Now if you use something called the R square, which is literally, by the way, R square, so all you got to do is you take R and you square it. Okay? So that gives us 0.64. And the R square is the percentage of the dependent variable that I can guess with the independent variable. Or at this point, since we're doing test 1 and test 3, is 64% of the performance of test 3 can be estimated using the performance of test 1. So basically, 64% of your grade on test 3 in this class could have been estimated with the performance of test 1. That's what the R square tells you. What percentage of the dependent variable you can estimate with the independent variable that you have. Alright, so in other words, it's a really strong dependency that I have here. Now, imagine that Professor Choi wants to estimate his test 3 score with his test 1 score. We could do that by using the regression equation that I have. So what I would have to do is I would have to have a test 1 score. So imagine that I scored a, say, 92 on my test 1, and I want to estimate my test 3 score. Now the way I would do that is, since I have a regression line, I basically just plug in my test 1 score on that X, so I can get an estimate for my test 3. And that's really the purpose of a regression. So my estimated test 3 score is going to be equal to negative 11.70 plus 1.098 times the 92 that I got on test 1. So figure out how much that is. Okay, so my y hat is equal to 89.32. Okay, so notice that what I'm doing here is I'm estimating my test 3 score with my test 1 score. And that's actually the usage or how people use regression equations. So imagine that you could estimate, say, the amount of copy machines that somebody's gonna sell using the amount of phone calls. Or imagine that you can estimate the amount of customers that walk into the store and how much is that related to the amount of sales in a store. Or imagine that you can relate the amount of clicks on a particular video by how many times that video shows up in your automatic portion on YouTube, for example. Okay, so regressions are for the purpose of estimating the two variable, estimating a dependent variable using an independent variable. All right, so anyway, you now know how to build a linear single variable regression. I just gave you everything you need. All right. Hopefully you start finding things that are related out there, and maybe one day you figure out that if it rains in Hawaii, the stock market goes up and we can all be rich. By the way, if you find something like that, let me know so Professor Choi can share some of that wealth. Have a good one.